And good morning, ladies and gentlemen. Welcome to the Simpkins Snowy Corner. It's snowing outside, but we got a little lesson here for you guys today. Week 22, Snow 2 FBDs, academic physics. So go ahead and click on that, download this puppy, and after you download this, then you can come back to the video here and take a couple notes along with us. Today, I'm going to give you just a couple of refreshers on F equals ma for unbalanced forces and Newton's second law. And then for today, I just want you to submit one sample problem after the lesson here to show me that you picked up on what I'm throwing down. So without further ado, here we go. So we look at these FBDs, or free body diagrams, and it's just a way to represent what forces are acting in a particular situation. Now, with this little, a quick little introduction here. If the net force, all right, sometimes we say net force, and we write it as sigma F equals ma. This means the sum of all the forces, or the net force. If the net force is 0, that means the forces are balanced in all directions. So look at this first picture. If there's 50 newtons to the right and all the forces are balanced, then there must be negative 50 newtons to the left, or force A. For force B, if there's 200 newtons down and the net force is 0, there's got to be 200 newtons up. So just remember, up and right are our positive directions, down and left are our negative directions. Let's look at the next one. If the net force is 900 newtons up, I'm actually going to flesh this out a little bit here with sigma F. All right, let's talk about sigma F. It means sum of the forces. And so the sum of the forces can be written as F equals ma. It can also be written as force 1 plus force 2. What do you mean? Well, let's call this force 1 and let's call this force 2, because there's two forces on it. The sum of the forces is equal to force 1 plus force 2. So if we do this carefully, check this out. Watch how this works. The net force is 900, which goes for this one. So 900 newtons. You see how that's the net force? I plugged that in for the sigma F. Equals F1, which is force C. We're not sure what it is, plus F2. Now, keep in mind, F2, the force 200 newtons, is down. So I'm going to actually write that as negative 200 newtons. And so now we just have a pretty basic math problem to solve here, which isn't that bad at all. If we have 900 equals C plus negative 200, then what we're going to have to do, I'll draw this in a different color, is add 200 newtons to both sides to cancel that out. And so as you look at this algebra here, you can see that force C would have to be equal to 1100 newtons. I would write that here, 1100 newtons, okay? And the reason that, and it makes sense if you think about it, look, 1100 newtons up, 200 newtons down would cancel or add up with the negative guy, right? 900 newtons, okay? So that's when the forces are unbalanced. You can figure it out by doing sigma F equals ma. You can do the same thing for the next one. Now, you notice this one says the net force is to the left, right? So that means that the up and down forces must be balanced. A classic example is anytime you're doing your lab or you have something sitting on a surface, right? Just the table pushes up, gravity pushes down, but they kind of wash out a little bit. And so if that's true, then E is negative 300, right? That's just going to be the opposite of the 300 up. But if our net force is 60 newtons left, let me do this in a different color. That means that the net force is equal to force 1 plus force 2. All right, and so the net force is 60, but I'm going to call it negative 60. Why did I call it negative 60? Because of the left, right? And then F1, it doesn't really matter which one we call F1 and F2, but we'll say negative 80, and that comes because this guy is to the left, plus F2. Now, if you solve for this, you'd have to add 80 to both sides. So add 80 to both sides, add 80 like that. And negative 60 plus 80 will get you a force of 20 newtons. And we can check that, right? 80 to the left, 20 to the right. 80 minus 20 is 60. 60 newtons to the left wins. Last one, it says the net force is 30 newtons to the right. Okay, so we can assume F is equal to H and H is equal to F. I'll just write it that way, right? Because the up and down forces are balanced because it doesn't indicate an unbalanced vertical force. If the net force is 30 newtons to the right, maybe you guys can just do this mental math. Look, if that's 50 minus 20 equals 30, right? The overall force is 30, so we basically just need 30 more newtons to the right than we have to the left. And that's why that answer is 50. Okay, so just a quick recap of what net force means. Don't forget, it actually does mean sum of the forces, so that's pretty important. Now let's look at an example of a word problem. Now we know anytime we do a physics problem, we want to look for the numbers right away. So I'm not even going to read the question yet. I'm just going to look at the numbers. Now let's read the question. It says, 2 kids pull on a wagon. Draw an FBD. One kid pulls to the right with a force of 25 newtons. The other kid pulls with a force to the left with 20 newtons. If the wagon has a mass of 30 kilograms, what is the acceleration of the wagon? So you notice as I was reading the problem, not only did I underline the numbers, but I turned the word problem into a picture. Because I don't know about you guys, but I like pictures. It's a lot less work than reading an entire paragraph, right? And just looking at this picture, a lot of you already know what the net force is. If we have 25 right and 20 left, then the net force is 5 newtons to the right. Now, if you're not sure how to do that, just to think about the strategy we just did. Sigma F is force number 1, 25 newtons, plus, add them up, negative 20 newtons. Why negative? Because it's to the left over there. And we get the same answer over here, of course, because it's the net force. So that's how you find the net force, is just by adding them up and remembering that left and down are negative numbers. Now it says use the net force in sigma F equals ma. All right, so we got our list of knowns, right? We have m equals 30, and we have sigma F equals 5 newtons. And I should be a good physicist and put my units here. And so the question did say, what is the acceleration of the wagon? So if I have my list of knowns, I write my blank equation, I put in my stuff into the equation in the appropriate places, like so. And all I have to do then is divide both sides by 30 kilograms, 30 kilograms. And my A would be whatever 5 over 30 is. It's 1 over 6. That's a gross fraction. Let me see what that is. What's 1 over 6? It's like less than 0.2, but 1 over 6 is, there you go, 0.1. That's what I was thinking, but it's early, so I don't want to make a mistake on the video here for you. So 0.167 meters per second squared, because it's acceleration. So that'd be solved for the unknown. I guess I just did step 4 in there. So anytime you see a force type of problem, that's the approach you want to do. You want to say, all right, what's my net force? And then do I know our mass or acceleration? And then how does that fit into sigma F equals ma? So let's do a little bit of practice here together real quick. All right, 2 raccoons moving a giant gumball. If a large raccoon can apply a force of 20 newtons, boom, there's the big one. And a small raccoon can apply a force of 5 newtons. Also, notice that I draw my bigger forces with longer arrows. That's because force is a vector, which means it has magnitude, how big the arrow is, and direction, which way it's going. So make sure you do that. It says, what's the net force if they both push in the same direction? Well, that net force over here would be 25 newtons, because we would say 20 plus 5. But it says, what if they put in opposite directions? So I guess there's actually 2 answers for this, but I'll just draw it like this. The net force for this one would be 15 newtons. Now, if you flip-flop them, it would be 15 newtons to the left, but you get the idea. And so we see that if you push together, the forces will add up. If you're pushing up opposite, forces will subtract. Not really rocket science there. What's the net force required to give a 100-kilogram car an acceleration of 4 meters per second squared to the left? Now, this is why I make you guys do, wait, force of gravity. Because force of gravity is weight, but kilograms is not weight. Kilograms is mass. All right, so you got to really remember that kilograms is telling us about mass. And so the mass is 1,000 kilograms. The acceleration is 4 meters per second squared. But it says to the left. Hey guys, what does that mean? It means negative. Okay, so that's a negative acceleration. So we set up our equation, sigma F equals ma. And it says what is the net force? So that's what we're solving for. Sigma F equals, and all you got to do is plug this guy in. So 1,000 kilograms times negative 4 meters per second squared. And that's going to get us a sigma F, or net force, of 4,000, and I should say negative 4,000 newtons. Not so bad. What would the acceleration? What acceleration would a net force of 10 to the right give a 1,000-kilogram car? So we write our knowns here. Our sigma F is equal to 10 newtons. Our mass is 1,000 kilograms. And it says what acceleration would we get? So sigma F equals ma relates these things together. 10 newtons equals 1,000 kilograms times a. Divide both sides by 1,000. That's a tiny number. I don't feel like doing mental math. It's too early, so I'm going to be lazy and put in my calculator over here. All right, 10 over 1,000. Yeah, that's what I thought. But I mean, like, again, guys, it's early. Give me a break. Okay, so 0.01, I don't even think the sun's up yet, meters per second squared. So, boom. That's a very small acceleration because, duh, guys, you're pushing a giant car with 10 newtons of force. It's not that much force, and it is a big car. All right, the rest of these guys, okay, here we go. 50 force to the right and 20 newtons of force to the left. That means the sigma F is equal to 30, okay, because 50 minus 20 equals 30. If the acceleration of the object is 6 meters per second squared, what's the mass of the object? So let's go ahead and fill this in here. Sigma F equals ma. 30 newtons equals mass times 6 meters per second squared. Divide both sides by that 6. I'm going to get a little fast and lazy here, but that's going to be 5 kilograms. Guys, show your work. I'm trying to get this video short for you. Then we have this last one, okay? So I'm going to do these two real quick. The car goes from 0 to 24 meters per second west in 6.2 seconds. Good Lord, there's a lot in there, okay? Check this out. M equals 2,000 kilograms. That's easy to identify. But let's not forget what acceleration is. Acceleration is a change in velocity over time, which can also be written as Vf minus Vi over t. Okay, so in this problem, you notice they give us meters per second. That's velocity, guys. And we go from 0 to 24, so we go 24 meters per second. But it does say west, and so it's actually negative 24, because west is one of our negative directions. So negative 24 minus 0 over 6.2, that's going to get us our acceleration, which just so happens to be negative 3.87 meters per second squared. Then it says what net force is required, so all we have to do to finish this one up is do sigma F equals ma. What's your m? Oh, I don't mean to do that. What's your m? Right there. What's your a? Right there. Multiply them together, you get a really big negative force. What's the weight? Wait. Force of gravity of Guadalupe on Earth. Well, Fg is mg. If you go to your equation sheet, look at the chapter 4 section, and all you have to do is take its mass. Oops, sorry, that would be a big boy right there. 100 kilograms times 9.8 meters per second squared, and it turns out that his force of gravity would be 980 newtons. All right, so that's how much Guadalupe would weigh. Here's what I want you guys to do today. I want you to turn in this problem. You try it. I want you to label this free body diagram and answer these 4 questions. So pay close attention right now. I'm going to show you how to do one and then follow the same steps and submit that to the Canvas assignment today after you do that. So here we go. What's the magnitude of the normal force? Well, the normal force is this upward force, and if you're sitting on a surface, then the force down has to equal the force up. So the normal force has to be 49 newtons. Where did I get that from? I got that from the force of gravity down has to be equal to the normal force up. So that's not too bad. Magnitude of the normal force is 49. Guys, normal force starts with N and so does net force, but they don't mean the same thing, okay? Normal force is always that upward pushing force, or I should say really, it's a perpendicularly pressing force against any surface. So that's your normal force for you. Net force means the sum of all the forces. What's the mass of the object? All right, well, I don't know, but we know that, force of gravity is mass times the gravitational acceleration, 9.8. And so watch this. The weight is 49 newtons, and I know the g is 9.8 meters per second squared. Oh, okay. I'm having a flashback to our web quest, because that's what we did in our web quest. So if you take 49, divide it by 9.8, gee willikers, Mr. Simpkins, isn't that convenient? The mass is exactly 5 kilograms, okay? So again, if you have the weight, you can get the mass. If you have the mass, you can get the weight using Fg equals mg. What's the net force in the horizontal direction? Well, the net force is the sum of the forces, right? So you do 30 newtons plus minus 5 newtons, because this is to the left, our friction, and that's going to be equal to 25 newtons. So that's our net force. The last part says, what's the resulting acceleration? Well, what's the resulting acceleration? Well, we know the sigma F equals 25 newtons, so that's how much overall force we're experiencing. And we know the object has a mass of 5 kilograms. And so when it says what's the resulting acceleration, well, the only way to relate F, M, and A is with sigma F equals ma. So that's 25 newtons equals 5 kilograms times A. And so A would be equal, you got to divide both sides by 5 here, right? A would be equal to 5 meters per second squared. So look at what I have right here. What you guys would do for your assignment is you would snip your answer. So let me grab my snipping tool here, and you would just, it's not gonna let me do that because I'm in the video. Okay, anyway, what I want you to do your assignment today, you'll see it in the assignment description, is I want you to do this problem where it says you try it. You'll notice it's got exactly the same setup, exactly the same questions, just some different numbers. So I just want to see if you guys are tracking with this idea. So head on over to Canvas after you're done watching this video. You can snip your work right out of here, boom, upload it to the Canvas assignment, and then you can go frolic in the wonderful frozen precipitation that we have outside. Ladies and gentlemen, I hope you enjoyed the show today. Make sure you like, subscribe, hit the notification bell so you get all the beautiful physics content coming your way. Until next time, I'm Mr. Simpkins in the Simpkins Physics Corner.